Welcome back to the Microsoft DP-600 Practice Questions Series, implementing analytic solutions using Microsoft Fabric. This is Episode 2. Today, we cover the complete case study 2, Litware, Incorporated. We show the full scenario first, exactly as it appears in the real exam, followed by all 9 questions from this case study, with thinking pauses and complete explanations. 9 questions. 1 case study. Approximately 25 minutes. Let's begin. Before we get to the questions, read through the full Litware case study carefully. All 9 questions in this episode are based on this scenario. Overview. Litware Incorporated is a manufacturing company with offices throughout North America. The analytics team contains data engineers, analytics engineers, data analysts, and data scientists. Existing environment. Litware has used a Microsoft Power BI tenant for 3 years. Litware has not enabled any Fabric capacities or features yet. Available data. Product data lives in a single table: product ID, product name, product category, list price. Customer satisfaction data spans 3 tables: survey, question, and response. 1 survey row plus 1 response row is added per question, per submission. The question table holds each question's text. The third question in every survey is always the overall satisfaction score. Customers can submit a survey after each purchase. Pricing groups, high, medium, low, are implemented inconsistently across several databases and semantic models. The analytics team has large volumes of data, some semi-structured, and wants to build a new Fabric data store. User problems and planned changes. Product pricing logic does not always match across the different implementations. Litware plans to enable Fabric and build a new data store as a proof of concept, a POC. The POC uses a Fabric trial capacity. Remaining users get Fabric access once the POC is complete. 3 workspaces will be created: Analytics POC, Data Eng POC, and Data Sci POC. Analytics POC holds the data store, semantic models, reports, pipelines, data flows, and notebooks. Planned changes. Continued. Data engineers load data to OneLake hourly or daily via pipelines, using low-code tools where possible. Analytics engineers ingest, transform, and load data into the Analytics POC data store daily. All semantic models and reports in Analytics POC will use the data store as their sole data source. Technical requirements. The data store must support T-SQL and Python read access, semi-structured and unstructured data, and row-level security for T-SQL users. Files land as Parquet, meeting the Delta Lake spec. Raw data loads untransformed, then is cleansed and merged into a dimensional model. Raw and cleansed data must fully update before the dimensional model populates. A date dimension is required. There is no existing source, covering 2010 through the end of the current year. Pricing group logic. 50 or less is low. Over 50 up to 1,000 is medium. Over 1,000 is high. Must be maintained by analytics engineers in one location. Available through both T-SQL and the default semantic model, TRZ. Security requirements. Only Fabric admins and the analytics team can see POC items. Data engineers. Read and write to the data store only. No dataset or report access. Analytics engineers. Read, write, create schemas, create and share semantic models, and view and modify all reports. Data scientists. Read only via a Spark notebook. Security requirements. Continued. Data analysts. Read only to dimensional model objects, plus report building access using semantic models the analytics engineers create. Litware already has these Microsoft Entra groups: Fabric admins, analytics team, data analysts, data scientists, data engineers, and analytics engineers. Report requirements. The customer satisfaction report must let users filter survey responses by a selected product and show the rolling 12-month average overall satisfaction score up to a selected date. It must reflect updates immediately, keep only current and previous year data, respect source table-level security, and minimize query execution time. The principle of least privilege applies throughout. Both the default and custom semantic models may include only tables and views from the dimensional model. You now have the complete Litware scenario. Questions 1 through 9 follow now. Question 1 of 9. Remember from the scenario, data engineers need read and write. Data analysts are limited to dimensional model objects. Data scientists are read-only via a Spark notebook. Task: you need to assign permissions for the data store in the Analytics POC workspace. The solution must meet the security requirements when you share the data store. Which additional permission should you assign to each group? Data engineers. Choose from. Build reports on the default dataset. Read all Apache Spark. Or read all SQL Analytics endpoint data. Data analysts, same 3 choices. Data scientists, same 3 choices. You have 30 seconds. Think about who needs raw file level access, who needs report build access only, and who needs strictly read-only notebook access. The correct answers are data engineers. Read all Apache Spark. Data analysts. Build reports on the default dataset. Data scientists. Read all Apache Spark. Why read all Apache Spark is correct for data engineers. They need to read from and write to the data store via pipelines and notebooks. Read all Apache Spark grants the raw file and table-level read access their notebook-heavy workflow needs. Why build reports is correct for data analysts. The requirement limits them to only the dimensional model objects. The default semantic model is built from exactly those objects, so granting report build access on it enforces that scope naturally. Why read all Apache Spark is correct for data scientists. The scenario explicitly says they access data using a Spark notebook, read-only. Read all Apache Spark grants exactly that, with no write permission to accidentally grant. Why not the alternatives? Read all SQL Analytics endpoint data would work for read-only access, but it doesn't match data engineers' write needs, and it would overexpose raw data to data analysts beyond their scope. Question 2 of 9. Important. This is a DAX code completion question with 2 fields to complete. Remember from the scenario. The report must show the rolling 12-month average overall satisfaction score up to a selected date. Task. You need to create a DAX measure to calculate the rolling 12-month average overall satisfaction score. The code reads, rolling 12 overall satisfaction equals VAR number of months equals 12. VAR last current date equals max of date column. VAR period equals dates in period of date column. Last current date, negative number of months, month. VAR result equals calculate. Open parenthesis, blank 1, comma, blank 2, comma, survey question, question title, equals, quote, overall satisfaction, quote, close parenthesis, return result. Field 1. Aggregation expression. Choose from average A of question text, average of survey response value, or AVERAGEX of values of survey customer key. Field 2. Filter argument. Choose from last current date, period, or number of months. You have 30 seconds. Think about which expression correctly averages a numeric value and which variable is a proper filter table, not a scalar. The correct answers are aggregation expression, average of survey response value, filter argument, period. Why average of response value is correct? The overall satisfaction score is a numeric response value in the survey table. A plain average is the correct aggregation. Average EA would incorrectly average text, and average X over customer key makes no numeric sense. Why period is correct? Period is the table variable produced by dates in period. Passing it as a calculate filter argument restricts the average to the rolling 12-month window, exactly what up to a selected date requires. Why the others are wrong? Last current date is a single date value, not a filter table. Calculate needs a table or Boolean filter, not a scalar. Number of months is just the integer 12. Passing a number does not filter anything inside calculate. Question 3 of 9. Important. This is a T-SQL code completion question with 2 fields to complete. Remember from the scenario. Pricing logic must be maintained by analytics engineers in one location, available via T-SQL, and the default semantic model. The logic, 50 or less is low, over 50 up to 1000 is medium, over 1000 is high. Task, you need to resolve the pricing group classification issue. The code reads, create, blank one, products with pricing group as select product ID, product name, product category, list price, case when list price less than or equal to 50. Then quote low quote, when blank 2, then quote medium quote, when list price greater than 1000. Then quote high quote, end as pricing group from dbo.products. Field 1, create method. Choose from procedure, view, or table. Field 2, medium clause. Choose from 3 variants of the list price comparison for the medium tier. You have 30 seconds. Think about which object type stays automatically current with no refresh step, and which comparison correctly classifies a product priced at exactly 1000. The correct answers are create method, view, medium clause, when list price between 50 and 1000. Why view is correct? The requirement says pricing logic must live in one place and stay current with no separate refresh step. A view recalculates on every query, always in sync, zero maintenance. A table would need a scheduled job to avoid going stale. Why between 50 and 1000 is correct? Case evaluates when clauses in order and stops at the first match. List price equal to 50 is already caught by the first clause, so between's inclusive lower bound never causes a conflict, and its inclusive upper bound correctly classifies list price equal to 1000 as medium. Why the others are wrong? List price greater than 50 and less than 1000 excludes list price equal to 1000. So a product priced at exactly 1000 falls through every when clause and returns null. That's a real classification bug. The greater than or equal variant has the same less than 1000 problem, and the extra or equal to 50 is redundant besides. Question 4 of 9. Remember from the scenario, analytics engineers prefer low-code tools wherever possible. Task: you need to recommend how to ingest the customer satisfaction data into the data store in the Analytics POC workspace. The solution must favor low-code tools where possible. What should you recommend? Option A, a stored procedure. Option B, a pipeline that contains a KQL activity. Option C, a data flow. Option D, a Spark notebook. OB. You have 30 seconds. Which option needs the least handwritten code? The correct answer is C, a data flow. Why a data flow is correct. Data flows provide low-code ingestion, transformation, and loading, exactly the preference the analytics engineers stated for as much of the pipeline as possible. Data flows also handle loading data untransformed into a staging area cleanly. Why the others are wrong. A stored procedure requires handwritten T-SQL logic. More code, not less. A KQL activity is built for querying custo or event data, not general customer data ingestion. A Spark notebook works, but requires more code than a data flow, not the low-code first choice. Question 5 of 9. Remember from the scenario, the data store must support T-SQL and Python read access, semi-structured and unstructured data, and row-level security for T-SQL users. Task: you need to recommend which type of data store to use in the Analytics POC workspace. The solution must meet the technical requirements. Which type of data store should you recommend? Option A, a data lake. Option B, a lakehouse. Option C, a warehouse. Option D, an external Hive metastore. You have 30 seconds. Which option natively supports both T-SQL and Python or Spark access? The correct answer is B, a lakehouse. Why a lakehouse is correct. A lakehouse supports both T-SQL and Python, or Spark read access, handles semi-structured and unstructured data, and stores files as Delta-compliant Parquet, matching every technical requirement in one item. Why the others are wrong. A plain data lake has no built-in T-SQL query engine or table structure. It is raw storage only. A warehouse is T-SQL first and does not support Python or Spark read access as naturally as a lakehouse. An external Hive metastore is a metadata catalog, not a Fabric native data store option here. Question 6 of 9. Important. This question has 5 options, and 2 are correct. Remember from the scenario, only Fabric admins and the analytics team should see POC items, and least privilege must be followed throughout. Task: you need to recommend a solution to prepare the tenant for the POC. Select 2 actions to perform from the Fabric admin portal. Option A, enable the Users Can Try Microsoft Fabric Paid Features option for the entire organization. Option B, enable the Allow Azure Active Directory guest users to access Microsoft Fabric option. Option C, enable the Users Can Try Microsoft Fabric Paid Features option for specific security groups. Option D, enable the Users Can Create Fabric items option and exclude specific security groups. Option E, Enable the Users Can Create Fabric Items option for specific security groups. You have 30 seconds. Which two options scope access to just the analytics team rather than everyone? The correct answers are C and E. Why trial features for specific groups works. Only Fabric admins and the analytics team should see POC items. Scoping the trial features toggle to specific security groups, not the whole org, is exactly least privilege in action. Why create items for specific groups also works. Same principle. Only the analytics team should be able to create Fabric items during the POC. So scoping creation rights to specific groups, rather than excluding groups, is the least privileged choice. Why the others are wrong. Enabling paid features for the entire organization hands trial access to everyone, the opposite of least privilege. Guest user access is about who can sign in from outside the tenant. It doesn't control who can try paid Fabric features or create items. Exclude specific groups still defaults everyone else in. Backwards from scoping access to just the analytics team. Question 7 of 9. Important. This is a drop-down selection question with 2 fields to complete. Remember from the scenario. The report must respect source table-level security, show updates immediately, and minimize query execution time. Task. You need to design a semantic model for the customer satisfaction report. Which data source authentication method and mode should you use? Field 1. Authentication method. Choose from Basic Authentication, Single Sign-On Authentication, or Service Principal Authentication. Field 2. Mode. Choose from Direct Query, Direct Lake, or Import. You have 30 seconds. Which authentication method passes through the user's identity, and which mode avoids both refresh lag and slow per visual queries? The correct answers are Authentication method, Single Sign-On, SSO, Authentication, Mode, Direct Lake. Why SSO authentication is correct. SSO passes the querying user's own identity through to the data store, so any table-level security defined at the source is enforced per user automatically, exactly what respects table-level security requires. Why Direct Lake is correct. Direct Lake reads Delta tables directly with near import level query speed but no refresh lag, satisfying both shows data as soon as it is updated and minimizes execution time of report queries at once. Why the others are wrong. Direct Query always reflects live data too, but typically queries the source per visual, slower than Direct Lake, and this scenario explicitly asks to minimize query time. Import requires a scheduled refresh, so it cannot show data as soon as it is updated. There's always a lag. Question 8 of 9. Important. This question has 4 options, and 2 are correct. Remember from the scenario. There is no existing source for the date dimension, and it must always contain 2010 through the end of the current year. Task. You need to implement the date dimension in the data store. The solution must meet the technical requirements. Select 2 ways to achieve the goal. Each correct answer presents a complete solution. Option A. Populate the date dimension view by using T-SQL. Option B. Populate the date dimension table by using a copy activity in a pipeline. Option C. Populate the date dimension table by using a data flow. Option D. Populate the date dimension table by using a stored procedure activity in a pipeline. You have 30 seconds. Which two options can generate brand new date rows rather than copy existing ones? The correct answers are C and D. Why a data flow works. There is no existing source for the date dimension, so it must be generated, not copied. A data flow using Power Query can generate a full 2010 through current year date list with M code, a low-code, repeatable generator. Why a stored procedure activity also works. A stored procedure activity can generate the same 2010 through current year range with a repeatable T-SQL loop, a second valid, robust way to populate the missing dates. Why the others are wrong. A T-SQL view over the requirement doesn't generate the missing date rows. There's no source table to base a view on. A copy activity moves existing data from a source to a destination. Since no source exists for the date dimension, there's nothing to copy. Question 9 of 9, the final question of this episode. Remember from the scenario, raw and cleansed data must be fully updated before the dimensional model populates. Task: you need to ensure the data loading activities in the Analytics POC workspace execute in the correct sequence. The solution must meet the technical requirements. What should you do? Option A. Create a data flow that has multiple steps and schedule the data flow. Option B. Create a pipeline that has dependencies between activities and schedule the pipeline. Option C. Create and schedule a Spark notebook. Option D. Create and schedule a Spark job definition. You have 30 seconds. Which option can make one step? Wait for another step to finish first. The correct answer is B, a pipeline with dependencies between activities. Why a dependency-based pipeline is correct. A pipeline lets each activity depend on the successful completion of the previous one, guaranteeing raw and cleansed data are fully updated before the dimensional model populates, exactly as required. Why the others are wrong. A single data flow with multiple steps runs as one unit. It cannot enforce dependencies against separate raw, cleanse, and transform items. A lone Spark notebook has no built-in mechanism to wait on other items completing first. A Spark job definition, like the notebook option, lacks native cross-item dependency orchestration. And that is all 9 questions for Case Study 2, Litware, Incorporated, the complete case study. The full answer key is on screen. Question 1. Read all Apache Spark, build reports, read all Apache Spark. Question 2. Average of response value plus period. Question 3. View plus between 50 and 1000. Question 4. Data flow. Question 5. Lakehouse. Question 6. C and E. Question 7. SSO authentication plus direct lake. Question 8. C and D. Question 9. Pipeline with dependencies. Drop your score in the comments. How many did you get right out of 9? In Episode 3, we move on to Case Study 3, Coming soon. Full scenario. More questions. Same format. Subscribe so you don't miss it. If this helped, please give it a like and share it with anyone preparing for DP-600. See you in Episode 3.